Okay, we have a warm-up right here. Please do these 3 problems. When it comes for the first one, you're simply asked to find a one-sided limit. We typically would actually try to eliminate the denominator, but we don't do it in this case because it's one-sided, which means we can actually explore it a little bit. When you have x minus 3, it means your graph has a, and let me go ahead and use a different color, boom, boom, boom. Your graph actually had a vertical asymptote, and the question is, how does it look like on the left and right hand side? If you look at the left-hand side, so a number that is, let's say, -4, then this answer is going to be, oh, by the way, +3, right? So let's say +2, then this fraction is going to be negative, which means that we should be looking like this on the left-hand side, and then the right-hand side will just look like this. Which means that if you approach 3, and you approach it from the positive side, meaning you're approaching it from this side, then you should be at infinity. For the second one, we're going to do the conjugate, and the reason why we're going to do the conjugate is because when you plug into the denominator, it becomes 0. So plug in the conjugate and see if you can find the limit. And for the last one, number 3, we said given the following graph, sketch approximation of the derivative. Well, we have some very steep slopes that are negative, so we're going to be coming from negative infinity, and at this point right here we have a 0. So from negative infinity we're going to be approaching, we're going to be coming from right there all the way to -1. I know that I'm not doing a good job talking right now. I really apologize. But I'm trying to do this quickly. Now, between this and this point, we actually have positive slopes. But how positive are they? In the middle, that's probably where the maximum steepness is. And I would give it a 4. So I would say a 4. So let me just do that. So over here, the slope seems to be about a 4. So that's why I went up 4. And then I go down again because these are negative slopes, which go all the way down to negative infinity. So that's why this is what the graph looks like. So the objective for the student is going to be students will evaluate limits approaching infinity. So let's do those. So in the first case, we have a polynomial. And for this polynomial, we typically, or for any polynomial, we typically care about the first term. And that's because when the limit goes to infinity, then this term is going to outweigh all of the other terms. That's also sometimes part of the concept of end behavior. So when you put a negative infinity into x to the 4th, that's positive infinity, but because there was a negative up front, that would be negative infinity. So that's the answer. Here's a nice little question. Ever wondered why a number divided by 0 is undefined, or 0 divided by a number is 0? Let's develop this a little bit further. Reciprocals of zeros in infinity. So if you have a fraction here, and the limit of the bottom part of the fraction, let me use a different color, the limit of this, as we approach c, equals 0, then you essentially have a fraction where you have 1 divided by 0. But because we're saying we're approaching 0, it's okay, we're doing good. So what happens? Well, let's look at this table. If you have these numbers right here, what would happen with the actual function? So you can kind of see that as the number becomes smaller and smaller and smaller, all the way where it's becoming closer and closer to 0, the function becomes becomes bigger, becomes very large. The difference between each one is a factor of 10, as the denominator was also decreasing by a factor of 10. So the idea is, if you have something where a fraction with a number on the bottom approaches 0, your answer should be infinity. In a reverse sense, if you have a fraction where the denominator doesn't go to 0, instead it becomes larger and larger and larger. Let's say g of x is going to infinity or is infinity, then your limit is going to be 0. And the reason is, if you have 1 divided by 10, that's going to be 0.1. That one's going to be 0.01, 0.001, 0.0001. It becomes smaller and smaller and smaller, so it makes sense that as this gets larger, this becomes smaller until we can just say that it equals to 0. So, and also we have a plus and minus that we didn't have before, because it doesn't matter if you approach 0 from negative or positive, it's still going to be 0. Where if you approach infinity from negative or positive, that's a vast difference. Negative infinity is very different from positive infinity. Here's a little theorem that we can use, or just a little fact. So at infinity, if r is a positive real number, then the limit as x approaches infinity of 1 over x to the r power would be 0. And that's simply because x becomes larger and larger and larger. Furthermore, if x is less than 0, then a limit as x approaches negative infinity would also equal to 0. And that's because x, the magnitude is still getting very, very large. So it's approaching 0. It's just approaching 0 from the other side. Alrighty, let's find the limit. So find the limit as x approaches infinity of 4 minus and then 3x squared, which can be rewritten as. So as you can see, you can separate limits. We talked about this in the past. So you can have the limit as x approaches infinity at 4, which simply just equals 4. And then you can have this bad boy right here. And in the previous slide, we talked about as x approaches infinity, for a fraction, even though you have a 3 instead of a 1, that will equal 0. And the only difference between having a 3 here versus not having a 3, it will be, it's either going to be 0 without the 3 if that was a 1, or it would have been 3 times 0, which is also just 0. So that's why we have 4 minus 0, which equals 4. So what happens when you have rational functions? So let's discuss that a little bit further. So let's say r is a rational function, which means that we have a top function and a bottom function, presumably being polynomials. What we only care about, if we approach infinity, are the biggest ones. That's very often also how we find the end behavior for a rational function. Unless you're trying to find the slant asymptote, that's a different process. But let's read what it says right here. If n is less than m, then y equals 0 is a horizontal asymptote of the graph r of x. If n equals m, then a equals a, that would be just the coefficients of both. So a over b, and that will be the horizontal asymptote of r of x. That makes sense, right? Because if m was larger, if m was a bigger beast, then you would see, let me just get a highlighter, this thing would be huge, which means you would end up having some large number going to infinity, but that would be above an even further larger number, which is going to infinity at a faster rate. So you have 1 over infinity, or a relatively small number over a big number. You're going to go ahead and make the claim that this fraction equals to 0. So the end behavior, or the horizontal asymptote, is going to be y equals 0. In the second case, they're the same. So the x's would cancel, leaving you with a over b. You would have a horizontal asymptote, it just wouldn't be at 0. So here's an example. We have 2x squared, and we have x squared. And they both have the same degree. We don't care about the 9, because the 9 becomes irrelevant when x approaches infinity. In this case, we only care about the end behavior. What happens as x approaches negative infinity? The x squares will cancel, leaving you with a 2. So the answer will be 2. The next ones, also, these are very simple problems. In this case, we're going to end up having the answer being 0. Whenever the answers end up being 0, it doesn't matter if it's like positive or negative infinity. It also, I'm trying to kill a mosquito right now. It also doesn't matter if there are negatives for coefficients. The only thing that in this case what matters is the bottom degree larger than the top degree? And it is. So the answer will be 0. It's kind of sad that you don't really need much more information, because this would have been a totally different beast had the degrees been the same. If the degree was the same, then you have to worry about How does the negative infinity react to the degree of the polynomial? It also would matter if the coefficients are positive or negative. And then you can have a more exciting answer, because it could be -3 or +3 or any other number. Here we have a AP release question. What's the limit as x approaches infinity of this fraction right here? In this case, the degrees that matter are right here. So my favorite pen, I don't have it on me right now, so I'm dealing with a really bad pen. But these have the highest degrees, so those are the ones that matter. They're also the same, which means that the answer could possibly be 1/4 or -1/4. The fact that it's infinity makes the problem a little bit easier. Had it been negative infinity, then you would have to worry about, will negative infinity remain negative in the degree of 2, or wouldn't it? But you don't have to worry about it, because it is already positive infinity. So as it is right now, to me it seems like it's going to be positive 1/4. But then you see that negative right here. So you're going to end up having pretty much 1/-4, which would give you the answer part B, or the answer B. So we have 4 more questions right here. They shouldn't take very long, and they're just based on principle. For instance, a limit as x approaches infinity for -x³. You want to know what -x³ looks like, and then just find out what the end behavior is at infinity, or the very right side. In this case, negative infinity would look like this, I believe, if I'm correct, which means that the answer will be negative infinity. Anyways, try out 2, 3, and 4 and get the answer so I can check them the next day. So, hopefully you paused the video and tried it on your own. So let's see what we have here. This fraction, the bottom has a larger degree. A larger degree. Therefore, the answer for this one's going to be y = 0. And I feel a little bit guilty, because I just realized that I kept saying the answer is 0, and I didn't really explain what I meant by that. Your answer for these things is pretty much not, it depends how you look at it. It could simply be your y is going to equal 0, literally, or it could also mean you have an asymptote at y = 0. In this particular one, the answer is y = 0. It's not an asymptote. They're asking what the limit would be as x approaches negative infinity, so y = 0. For the next one, we approach negative infinity, which is not relevant, since we have a higher degree on the bottom, x².
That tone indicates it's time to go to 8th period. Thank you.
Alrighty, I am going to leave that in the video. So that answer will be y = 0 as well. And we're actually talking about a point. And for the last one, now over here we have to be not as mindful, it's just infinity. And again, it's hard to highlight with a pen. We have the degrees being the same. We have x approaching positive infinity. So the answer is going to be -3. Y = -3. I'm just going to use my highlighter. Y = -3. And the perpetrator for the negative is that sign right there. Because of this guy, you got y = -3. That's it. See you guys tomorrow.